Here's another example of proving trig identities. I will call this example set 3. Okay, first of all, prove that cotangent squared equals cosecant of theta minus sine of theta all over sine of theta. The right-hand side is obviously more complicated, so I will choose that as my starting side. I want to take that right-hand side, and working only with the right-hand side, I need to simplify it to cotangent squared of theta. Now, on this particular problem, I see something similar to something I've seen before. I see a fraction, and I see in the denominator of that fraction a single term. I've learned that I can split my fraction over that single denominator. And so the first thing here that I will do is I will take and I will split this fraction apart. I have cosecant of theta over sine of theta minus sine of theta over sine of theta. Okay, from here, everything is in terms of sine of theta except for the cosecant. I will rewrite that cosecant in terms of sine. Cosecant is 1 over sine of theta. So the numerator turns into 1 over sine of theta. The denominator is still sine of theta. My second term is sine theta over sine theta. That reduces to 1. The same value over the same value equals 1. Okay. With the first term, 1 divided by sine of theta, all divided by sine of theta, is actually a division of fraction problem. The bottom sine theta needs to be put over 1. My rule for dividing fractions is that I keep the first fraction, 1 over sine of theta. I change division to multiplication, and then I flip the second fraction. The fraction on the bottom is sine theta over 1. It needs to be flipped to 1 over sine of theta. I'll keep the minus 1. Now, that being the case, 1 over sine of theta times 1 over sine of theta can be reduced to 1 over sine squared of theta. I multiplied these two fractions together. Okay, next, 1 over sine squared of theta can be rewritten using a reciprocal identity. The reciprocal of sine is cosecant. I would leave the squared on the function. So in other words, 1 over sine squared of theta is equal to cosecant squared of theta. Okay, now at this point, cosecant squared of theta minus 1 reminds me of a Pythagorean identity. The Pythagorean identity is that 1 plus cotangent squared of theta equals cosecant squared of theta. However, we need to use an alternate form. One of the alternate forms for this identity is that cotangent squared of theta equals cosecant squared of theta minus 1. We see that what we have is we have the right-hand side. We can substitute in the left-hand side. And so this simplifies to cotangent squared of theta. That was my desired result from what I have up above. I had wanted to prove that the right-hand side equaled cotangent squared of theta, and that is what I've done. This concludes this example of solving trig identities.